when you think about real-time visualization and analytics, it is about integrating the sensor networks and the IoT data, bringing all that information together. Now, many of you have operation systems in place today. And in those centers, you're ingesting SCADA information, you're bringing in historian data, you're tracking personnel, you're tracking ships and vessels through AIS, bringing in real-time weather feeds, and you're bringing that into this operational view, which effectively allows you to make up-to-date and timely decisions. Now, at Esri, we've been supporting you in this for a while with Enterprise and Geo Event Server, but now we have this capability available through ArcGIS Online and ArcGIS Velocity. So now I'm going to ask my colleague, Matt Ballard, to give us a demonstration. Matt?
In this era of the digital oil field, IoT sensors and other real-time data feeds are supporting remote operations, driving efficiency and reducing operational costs. For example, critical assets are being monitored by SCADA systems. Green dots represent equipment that are operating normally, whereas red indicates an issue that needs to be responded to, such as a meter with high tubing pressure in this case, or high volume tanks in these tank batteries. Vehicle and employee locations are another source of real-time data that can be used to optimize operations. You can know who is where and quickly contact the closest employee to an issue so that you can manage your operations by exception. The challenge is how we consume these diverse streams of data and leverage them to understand and improve operations. ArcGIS includes scalable real-time and big data analytics that can make use of these data streams. You can build automated services to ingest, transform, and analyze data, taking action along the way. With ArcGIS Velocity, you can get started by creating a feed. A feed enables you to connect ArcGIS to IoT systems like cloud platforms and messaging brokers. You connect to the data stream, configure a data model, and then publish a continuous cloud-hosted service that ingests data and lights up your maps with streaming information. But what's really valuable about this is that you can use real-time analytics to synthesize these data streams, weather, employees, assets, and use them to better understand and optimize your operations. For example, you could automatically detect who the nearest employee is to an issue so that you can have them go out there and respond, and you can send them a notification. Or we could be using these well pad boundaries as geofences to determine where our employees are. This analytic is automating the process of determining whether an employee is on-site or traveling. First, we bring in our location feed for our vehicles and our well pad boundaries as geofences. Then we use a series of tools to analyze each event as it arrives. The output is sent to a layer which can be added to my maps and dashboards, and as an email notification, which can be sent to management under certain circumstances. You can put together real-time and big data analytics like these in just a matter of minutes without writing a single line of code. And now in my dashboard, I have an instantaneous perspective into the status of personnel, whether they're on-site or traveling, and I can quickly click on them to go show me their current location. Over time, these sources of real-time data can be stored and analyzed to uncover patterns and trends in your data. For example, a fleet of just 100 vehicles every 10 seconds adds up to almost 1 million points every day. ArcGIS Velocity can aggregate these data sets for rapid and dynamic visualization and analysis. Each bin is labeled with the number of points that falls inside of it. And to ensure that our facilities are operating efficiently and safely, we need to make sure that we're visiting them on a regular basis. We can use these GPS tracks to understand when facilities have been visited recently, when they haven't, and use that to better plan work. In this model, we ingest our vehicle GPS data as well as well pads and operating areas, and we determine when a facility was last visited by aggregating it. This spatially aggregated data, we can use it to mark a well pad as visited or not visited and include the date that the visit occurred. This model is also handling several processes though. It's also determining the percentage of sites that are being visited each day to track against goals, using spatial joins, summary statistics, and field calculations, all in a completely automated workflow. These analytics can run once, periodically, such as every minute, or at a reoccurring time, in this case, every night at midnight. The map now informs us of sites that need to be visited. Red ones indicating that they haven't been visited recently and should be at the top of our list to make sure that they're operating safely and effectively. In this chart at the bottom right allows us to track our operational goals. For example, clarifying whether the percentage of sites visited in each operating area is on target or declining. As the digital oil field grows and new sensors come online, operators can be prepared to leverage this data to drive efficiency in operations. With scalable real-time and big data analytics, ArcGIS enables you to apply location to monitor your operations, respond to issues, and generate new insights. Thank you.
Matt, that was really a fantastic demonstration. I love that one because it really shows you the ability to ingest and visualize the information, but also more importantly, right, be able to perform an analytic on it, be able to gain additional insight and then take action. So it's a really great example of real-time visualization and analytics.